Greetings, scholars. That would be my children in the background laughing. Hold on, let me shut the door. Greetings, scholars. This is part 4 for your final review. You may not recognize this picture, but it is a football. And the football has been kicked from here. And it's going up, 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 right to the very tip top, and then down. So this right here, I'm going to call it point A. I'm going to call this point B, and this one point C. So A is actually, I'm going to go ahead and tell you that it is on the way up. All right, point B is at the very tip top. Okay, so there, point B is at the very tip top of the arc, okay, or we'll say the trajectory. And then finally, point C is on the way down. So I have a few different questions for you. My very first question is, what is the velocity vector in the x direction? Okay, so the horizontal velocity vector at both, at all three, A, B, and C. How is this football moving horizontally at all 3 points, A, B, and C? So I'm talking, is it going up, is it going down, right, left, or not at all? Okay? Okay, so I'm gonna go ahead and hit pause or whatever on Edpuzzle. You're gonna answer this. Click. The horizontal velocity at point A, well, we know that it's going up, but I'm not worried about up. Okay, I'm worried about the x direction. I shouldn't say like that. I'm worried about the x direction. Well, I can see clearly that the x velocity direction is going this way. What about the very tip top of the trajectory or the arc? Hey, in the x direction, it's still going that way. And at point C in the x direction, it's still going that way. So A, B, and C are all constant, okay, to the right. All of these answers. There's no acceleration in the x direction. Okay, so now let's look at it from another point of view. What about the vertical direction or the y direction? What are the velocity vectors at point A, B, and C? So you can take a second. Obviously, it'll be multiple choice. Take a second answer. I'll use blue. Well, right here, your football it's on the way up, right? And the C football, we know it's on the way down. So the vertical direction of the motion, okay, of the velocity, I should be more specific, the velocity, okay, it's up at point A. And at C, it's down. So remember we talked about throwing something straight up in the air and having it come back down. What happened at that infinitesimally small point in time when it actually reaches the tip top of the arc, I would say, or the tip top of the trajectory? What happens to the velocity? For an infinitesimally small point in time, it is actually 0. That is the y velocity, okay? The velocity in the vertical direction, up and down. My last question for you. Whoa, what about the acceleration? Which way does the acceleration point at all 3 of these locations? Location A, B, and C. What is your acceleration doing? So you'll see the multiple choice questions. They'll have specific answers. I'm only asking about direction, okay? Not speeding, slowing. I'm simply asking about the direction. You're going to answer those. Is anything touching that football? Right here. After it's been kicked, here's your foot and it's off your foot. There's absolutely nothing touching that football, but there is a force. And that force is what? Gravity. Because does your football float away into outer space forever and ever like a helium balloon? No, it doesn't. That's because there is gravity pulling it down. So there is no other acceleration on the football at this point. Now, these are velocity vectors, not acceleration. They're different. The only acceleration this is experiencing is g, which is 9.8 meters per second. How can it be traveling upward and have a downward acceleration? I want you to think back to the number 1 and number 2 video you just watched. If you have initial velocity going up and you have acceleration going down, what is happening to your object? It is doing what? If they are in opposite directions, you would expect that it is slowing down. And in fact, it is, right? Because as it goes up, it goes fast, slow, 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 fast, fast, fast. This makes sense. It makes sense. Don't overthink it. It makes sense. Velocity is up, acceleration is down. It is slowing. What? That makes sense. Next. Is anything touching B? But does it have mass? Is it on the planet Earth? Boom. Acceleration, straight down. It's at 9.8 meters per second squared. What about right here? Same thing. Nothing is touching it. The acceleration is down. It is also 9.8 meters per second squared. I want you to think about this one more time. At this point, what is your y velocity? The y velocity is down. Oh, your acceleration is down. Hey, what's happening here? You know, it's speeding up. It's speeding up which way? Well, it's speeding up in the downward direction, but it is speeding up at that point. It is very important that you understand all 3 of these things. You need to understand the horizontal velocity at each point, the vertical velocity at each point, and the acceleration at each point. Yay, my gift to you, a big heart with a smiley face.